What is Arduino? Who is Arduino? Why Arduino? In this video, we are going to answer all of those questions and cover all the basics of Arduino in just 20 minutes. Trust me, even Asian parents could be happier than this. So let's get started. By the way, this video is just an introduction video, but there's way more to come. We have a whole playlist for Arduino filled with DIY projects and tutorials for sensors and modules. So, what is Arduino? The first thing is, this is not Arduino. Arduino is actually a company based in Italy that creates and sell these things. They call them Arduino boards. These boards come in all sorts of shapes and sizes. You'll find versions like Arduino Mega, Arduino Uno, and Arduino Nano, and more advanced boards even come with built-in Wi-Fi and other fancy features. However, the most famous and widely used Arduino board is the Arduino Uno R3. The best thing is Arduino open sources all their designs. So you have many options from different creators, and because of the competition you can get them very cheaply. I recommend buying an Arduino kit when buying Arduino. But why is Arduino Uno so popular? To answer that, we need to first understand how an Arduino board works. So Arduino boards are equipped with a small microcontroller, a tiny low-power computer. These microcontrollers can run on battery for days, but are so powerful that they can process data faster than any human on the planet. While you could just use a microcontroller itself, you would need to handle all sorts of additional components and program it in complex languages. The process can be quite difficult and frustrating. But Arduino simplifies all of that, and the company has done an excellent job of creating hardware and software that are as easy as possible to use. Let's get familiar with the hardware. The Arduino Uno itself is not a microcontroller, it is more of a board. The microcontroller is this small tiny chip right here, with that we have talked earlier. Additionally, here's another tiny chip that handles serial communication for the Arduino board. This chip manages the communication between your computer and the Arduino board or other modules. You can upload code to the Arduino board using the USB port. The serial communication chip ensures that the code is properly managed and stored in the microcontroller. The 0 and 1 chip on the Arduino board also are directly connected with this chip, and they cannot be used. Let's talk about powering the Arduino. Arduino boards are like electronic devices that need power to operate. You can power an Arduino using the USB port, a special power jack, and this VN pin. You can provide 7 to 12 volt DC to these inputs. The built-in voltage regulator converts the input to 5 volt, which is the logic level the Arduino uses. Digital signals sent or received by the Arduino operate at a maximum of 5 volts. Okay, now let's talk about some important stuff. Let's understand the Arduino pins. Not gonna lie, Arduino has done a fantastic job at organizing the pin layout. The Arduino Uno has several types of pins: digital pins, analog pins, and power pins. The pin number 2 to 13 are digital pins. These pins can input or output digital signals. Some of them can also be used for PWM, which we will talk later in the video. Pins 0 and 1 are reserved for serial communication and shouldn't be used unless necessary. Analog pins, on the other hand, can only input analog signals. Unlike digital pins, they cannot output analog signals. Power pins. Power pins are used to give power to Arduino or draw power from Arduino. The Arduino can provide a maximum of 5 volts and support a current between 500 milliamps and 800 milliamps. Woo! Okay, now let's talk about the other basic and small components used with Arduinos. The first one is these jumper wires. These jumper wires are basically wires, and they come in all sorts of different sizes. We have larger ones, we have way too much larger, and we even have different version of them. They basically do what other wires do, but they become very powerful when they are used with this thing called breadboard. It is called a breadboard because it has many holes, just like a bread. Breadboard helps us prevent soldering. If I supply power to this pin, the pin down there, I can easily access the power from here. Meaning these pins are shorted column wise. But if I this is the powering cable, I cannot get the power even beside him. Or neither do here because of this gap. But when it comes to these rows, they are the opposite. These are usually used for power. And if I supply power to here, I can get it from all the way right over here, but not here, not here. And you got the idea. These may look very simple, but they can really be used with some other microcontrollers like ESP32. We even use some different modules like DF Layer Mini and connect all sorts of other components directly on them. And the best part is, and you can also connect different breadboards to have a bigger one, or if you want small, we have different sizes like this. Now, let's have example how can you use these. You don't need to know anything about this, but this is just to tell you that these come very handy. Okay, now let's talk about some other hardware used with Arduino boards. Remember, the breadboard and jumper wires were the basic components you can use with Arduino. But always remember you can use a wide variety of sensors, modules, and even shields with Arduino boards. Here are some examples to you to have that itch of buying all of them. Talking about sensor, we have IR sensor for detecting infrared signals, ultrasonic sensor for distance measurement, IR distance sensor, sound sensor, and even thermal sensor. Talking about modules, Arduino supports countless modules that extend its functionality, such as Wi-Fi modules for IoT projects, motor drivers for robotics, display module like this screen, joystick module, and even RFID modules. They are way more than even I can count, so let's talk about shields. Shields are add-on boards that stack on top of Arduino to simplify specific tasks like Ethernet connectivity, motor control, or even prototyping. By combining the Arduino board with these components, you can build almost anything from basic LED blinkers to advanced robots and even smart home devices. It's all up to you. Don't worry, we'll teach you everything how to use these components with Arduino board in the upcoming episodes. If you have made this far in the video, it really means you are eager to learn how Arduino works. So let's dive into the most important part, coding. This is where you'll spend most of your time. But don't worry, Arduino has made it as big and friendly as possible. To make coding simple, Arduino developed a special program called Arduino IDE, Integrated Development Environment. This software helps the user write and upload code to their Arduino board with ease. You can download the official Arduino IDE from the link in the description. During installation, if it prompts you to install any drivers, make sure to click yes. These drivers are essential for proper communication between your PC and the Arduino board. So you have downloaded the IDE. Let's try to get familiar with it. The first thing is this file button where you can upload, where you can open new sketch, open new cloud sketch. Sketch is basically a name of a program file of Arduino. And then the most important part is this examples. Arduino has done a fantastic job and they have built in all the examples from basic to advanced. If you want to learn Arduino professionally, make sure to check these out. The next thing is edit where you can do undo, redo, cut, copy, paste, etc. Then you have a sketch where you can verify, compile and upload. Verify means checking your code for error and upload means giving it to Arduino. Compile means turning the code, converting it to a machine understandable code. Then we have tool. Always make sure to select the right board and the right port. And then we have these buttons for verify, upload, and you can select the board from here. And then we have serial plotter and the serial monitor. Then we have sketchbook where you will find all of your project sketches locally on your PC and from the cloud. Then you have board manager. Remember, Arduino IDE can also be used to program all sorts of other boards like ESP32, etc. But you have to download a board manager first. But for Arduino Uno, it is built in, so we don't need to worry. Then we have Library Manager. Arduino provides all sorts of different libraries that you can download from the IDE, which makes specific tasks easy. For now, we don't need them, so close them. So this is the basic sketch you will always find in DI. Always find void setup and the void loop. Void setup and void loops are basically two different functions. Function can perform a specific task. For example, void loop always runs repeatedly, and the void setup can only run once. You can find that these are functions because of these brackets. Whenever you see a brackets, close bracket like this, is a symbol of a function. So what do we need to run once? For this, let's learn from example. Example, you tell a person a direction of a place. You telling them direction can be go in the void setup because you only tell them once. And walking of them can be go in the void loop. You can constantly tell them the direction every millisecond, but it is not necessary. Same. The code that we put in the void setup can be go in the void loop, but it wastes a lot of CPU time. And we usually put some code here and the main code in the void loop. So learn these more, we will use a simple example of turning on a LED. So we will do the hardware or the wiring first. So let's plug the Arduino to the PC, and now we're going to use a simple LED. I am going to use this LED. Always remember, the longer leg of LED goes to the live or positive and the shorter one is for ground or negative. So let's put into the breadboard. The other thing is the amount of current that Arduino gives to the LED can burn it. So to resist the current, we use a resistor. A resistor is a very handy tool or component. It can resist the current, so it helps our LED not to burn out. So let's use simple jumper wires. We are going to connect the LED to the digital pin number 8, and then the resistor can go to the ground. Another thing, a resistor can be go either to the ground or the positive, but I have used it for the ground. You can use it whatever you want. So now let's do the coding. So to turn on the LED, we first need to tell the Arduino what is the mode of that pin. Arduino digital pins have two modes, input or output. To tell the Arduino the mode of pin, we can use the function pin mode and the number of pin, which is 8, then comma, and then the main thing, input or output, which in my case is output. Because Arduino IDE uses C++, we need to put semicolon in the end of every line. Semicolon tells the Arduino that this is the end of line. But if a function like this void setup is using curly brackets, we would not put semicolons. Example, this would be an error. But not putting semicolon here would also be an error. Pin mode, mode of pin, pin number 8 is output. This line will tell the Arduino that digital pin number 8 is being used for output. And then we use the main function, which is the digital write and then curly bracket because it's a function, and then pin number, which is 8, and then high. High in Arduino means that give the that pin 5 volts, or low means take 5 volts from that pin, or minus 5. This line of code is going to tell the Arduino give the pin number 8 5 volts. Let's check. Let's upload the code and check. Okay, now let's learn from another example of linking the LED. In Arduino, just turning on and turning off the LED immediately would not give you the result of blinking because the process would happen so fast you won't be able to notice it. For that solution, we use a delay function. Delay function does what it means. It delays the execution of program for a given amount of milliseconds. To delay the program for 1 second, we will use delay 1000. What this program will do, it will turn on the LED, then wait for 1 second, then turn off the LED, and then wait for 1 second again. We can make this smaller by just 100 milliseconds. Let's upload the code and check. Okay, now let's learn if statement. If statement is a very powerful function in C++. If statement can decide to skip or execute some line of code on the basis of condition. For example, if then the condition, for example, I can put 9 greater than 0. And now the main code goes here. For example, now if statement will check if the condition is true or not, which 9 is greater than 0. So this line of code will execute. But if there's something like this, minus 9 greater than 0, which we know it's not, then these line of code will be completely skipped. With if we can actually use else. Else works like if, but only get executed when if turns out to be false. For example, we know that minus 9 is not greater than 0. The program will come and check if minus 9 is greater than 0, which we know it's not. It will skip these value and only execute this. But if the condition was 9 greater than 0, only this line of code will get executed and this will get skipped. Except of greater than smaller than, we can use equal sign. Remember, equal equal is different from equal. This is a equal and this is equal equal. Now this is used to check if 9 is equal to 0 or not, which we know it's not. We can also use OR. Now what will this do? It will first check if 9 is equal to 0 or 9 is equal to 9. Even one of them comes out to be true, if will execute this line and skip this one. But if there was AND, both of them needs to be true to get this executed, or else this will execute. This was if, but we can not only use constant like 9 only, we can use variables. What are variables? To understand the concept of variable, let's take example of a box. You can put anything in a box, any numerical value. In variables in C++, you need to first declare the data type. There are three kinds of variables: integers, decimal, and character. For integer values, you first type in then the name of variable which you can decide, which is fish, and then give it a value by putting an equal sign and then putting in a value. Now you can easily check that if fish is equal to 8, because we know it is, so this line of code will get executed. Now I want to teach you the if. Let's learn how to use a button with Arduino. To use a button with Arduino, let's do the wiring. Let's put a button first, and then one pin, upper pin one of them can be go to 5 volts, and then the other can go to the digital pin of your requirement. For example, I'm going with 4. But remember one important thing, always use a resistor with the wire you are using. It prevents unstable values from the button. This is called a pull-up resistor. Connect the resistor to ground. If this resistor is not put, unstable values will be given to Arduino, which will not work and you will be frustrated. So always use a resistor. Let's do the coding. So to use the button with Arduino, we first need to tell the mode of the pin using with Arduino. So we use pin mode, number of pin which is 4, and then input. After that, we're gonna use if statement. Then we use digital read command. Then number of pin which is 4, and then equal high. After that, we put a curly bracket, and this time we use digital write command for the pin number 8 with the LED. After if statement, we're going to use the else statement. And in this, we're going to put digital write command for pin number 8 for LED to go low. And for reducing debouncing, we can use a small delay. Let's see what will this code do. This code knows that pin number 4 is for input. It's going to first check if the pin is high, meaning the button is pressed, it's going to make the LED on. Else, it's going to make the LED low. Let's upload the code and check. So first of all, well done to the amount of people who have stayed this far in the video. Like and subscribe my video if you think you have learned anything in this video. I did want to teach you more, but because of the short time of this video, I couldn't. But don't worry, there's going to be a whole playlist just for you to watch. So go watch and learn. But for now, I am Mr. Big Brain